All right, so we're looking at second order differential equation. All right, so let's try and go through the explanation of how the author of the book that we are using came up with the solution, or how whoever came up with the solution first, what was their thought process, how did they come up with the solution, leaving behind a pattern that we can follow to solve equations of a similar form. So second order differential equations. An equation is second order when the highest derivative in the equation is the second derivative. Let us consider second order differential equation of the form a d2y by dx squared plus b dy by dx plus cy is equal to 0. I'm reading that thing in the shaded box to the left. A differential equation of this form is called a homogeneous differential equation, where a, b, and c are constants. Now, to solve this equation, we let y is equal to e to the mx, where m is a constant. So since y is equal to the mx, dy by dx is m, e to the mx. Remember, if you differentiate e to the mx, you get e to the mx, but you have to multiply by the differential of the inside function. That is how you get m, e to the mx, and d2y by dx squared is m squared e to the mx. Now substituting in a dy by dx, sorry, d2y by dx squared plus b dy by dx plus cy is equal to 0. We get a mx squared e to the mx plus b m e to the mx plus c e to the mx. Obviously, e to the mx is common, so to factor it out. So we have e to the mx into am squared plus bm plus c is equal to 0. Now, if you're multiplying two things and you're getting 0, it is either the first is 0 or the second is 0. Well, we all know that e to the mx cannot be 0. All right, e to the mx cannot be 0. Therefore, it is am squared plus bm plus c that is equal to 0. Now, am squared plus bm plus c is equal to 0 is called the auxiliary quadratic equation, or AQE. Now, for the AQE, the auxiliary quadratic equation, the coefficient of d2y by dx is the coefficient of m squared. The coefficient of dy by dx is the coefficient of m, and the coefficient of y is the constant in the AQE. Now, the solution of the second order differential equation depends on the root of the auxiliary quadratic equation. Recall that there are three types of root for a quadratic equation. The roots could be real and equal. The roots could be real and distinct, and the roots could be complex. Now, we're looking at these three scenarios, and these are the three possible outcomes. Now, when the roots of the AQE, which is the auxiliary quadratic equation, are equal or real and equal, the general solution of the differential equation is y is equal to a to the x plus b e to the m1x, where m1 is the solution of the auxiliary quadratic equation. Now, when the roots of the auxiliary quadratic equation are equal and distinct, the general solution of the differential equation is y is equal to a e to the m1x plus b e to the m2x, when m1 and m2 are the solutions of the auxiliary quadratic equation. Now, when the roots are complex, meaning that m is equal to m1 plus or minus I m2. So m1 would be the real part of the solution, and m2 would be the imaginary part of the solution. All right, then the solution would be e to the m1x. Remember, m1 again is the real part of the solution of the AQE when the roots are complex, into a cos m2x plus b sine m2x, where m2 is the imaginary part of the solution of the AQE when the roots are complex. All right, with this in mind, let's have a go at example 9. Example 9 says, solve the differential equation d2y by dx squared plus 2dy by dx plus y is equal to 0. So for every equation of this form, to solve, you would need the AQE. The AQE is auxiliary quadratic equation, and it is m squared plus 2m plus 1 is equal to 0, where the coefficient of m squared would be the coefficient of d2y by dx squared. The coefficient of m would be the coefficient of dy by dx, and the constant term of the AQE would be the coefficient of y, Now, if we solve this, we're going to end up with, if we factorize this, we're going to end up with m plus 1 multiplied by m plus 1 is equal to 0. So m plus 1 is equal to 0. And we say that m, let's spell it out, is equal to 0, or m plus 1 is equal to 0. So m is equal to minus 1 twice. So in this case, the solution of the AQE, the solution is real. The solutions are real and they are equal. If that is the case, the solution of the differential equation is y is equal to ax plus b e to the minus 1x, where the minus 1 is actually the solution of the AQE. All right, so example 10, we're asked to solve the differential equation d2y by dx squared plus 10 dy by dx plus 25y is equal to 0. To solve a differential equation of this form, you need the AQE, which is the auxiliary quadratic equation, which is m squared plus 10m plus 25 is equal to 0, where the coefficient of m squared is the same as the coefficient of d2y by dx squared. The coefficient of m is the same as what? The coefficient of dy by dx, and the constant is the same as the coefficient of y. All right, in solving this, we need to first factorize. We have m 5 plus is equal to 0. So m plus 5 is equal to 0, or m plus 5 is equal to 0. Therefore, m is equal to minus 5 twice. So in other words, the solution of the auxiliary quadratic equation, the solutions are real and they are equal. So therefore, the solution of the differential equation is y is equal to a x plus b e to the minus 5x, where minus 5 is the solution of the auxiliary quadratic equation.